Today we are gonna solve the lead code problem of the day, which is interleaving string, which is a medium problem tag, but it is a simple problem. I think. Like the first, we have to understand the problem. We are given three strings s1, s2, and s3, and s3 is formed by interleaving of s1 and s2. So how do you mean by interleaving? So Let's see with that example. What do you mean by interleaving? Suppose we have a string s1 which is AABC, s2 which is uh, DBBCA, and one is s3 which is AADBBCBCAC. Now we have to make s3 using s1 and s2, and not only s1 and s2, we have to interleave these two strings. Now, what is interleave? Now we can see this first double A, and we have taken this double A from S1. Then D, B, B, C. We have taken this from S2. Then we have taken B, C from S1, and A, then A from S2, and finally C from S1. So what is interleaving? Let's see. So if S3 is a string, we can interleave it like this: S1 plus T1. If S is S1 plus S2 plus dot 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 Sn, and T is T1 plus T2 plus dot 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 Tm. So interleaving of S3 will be like this: S1 plus T1. That means we have to take one substring from here, then one substring from there, one substring from S and one substring from T. Okay, then we have to concatenate these all, and if this concatenation forms S3, we can say that S3 can be formed by interleaving of S1 and S2. Okay. uh, Now we have some test cases. Like this is the first test case. We can see that by interleaving of S1 and S2, we can form S3. We have example 2, which is double A B C C, D double B C A, and double A D double B B A triple C. Okay. Now look over this test case. The output is false. That means we cannot form S3 by the interleaving of S1 and S2. Let's see. Okay. So let's see. Okay. So first we have A. We can start from A and D, and one pointer we can place here A. Now in S1 we have A, in S2 we have D, in S2 we have A. So we need A. From where we can take this A? From S1. Okay. So from S1 we can take this A. Okay, no problem. We have taken this. No problem. Now, if we take A from S1, we can say that S1 will be increased by one place. Okay, so now it is here. Okay, and also this A has been taken, so we can omit this A. Got it? Okay, now we need another A. From where we can take this? A, D. Obviously, this is not A, so we can't take it from S2. We have to take it from S1. Okay, so just take it. Just take it. Okay, so we have taken this A. We have taken this A. Omit it. Okay. So we have taken this and we have taken this. Now what do we need? D, and our pointer here is on B and here is on D. So we need D, so we can take it from S2. Okay, so S2. Okay, so we have taken D. Okay, so our pointer on S2 is now on B. Okay, now we have to take B. Now see, we have B on S1 and we have B on S2. So we have to take S1 or S2, but we don't know. Whichever will give me answer true, or whichever, if we take whatever or whichever we will take, it will form S3. So first we can take S1 B, then we can take S2 B. Whichever will give me answer that I am ready to form S3. Okay, I will take it and return that it is, it can be formed by interleaving S1 and S2. Okay, so first of all, let's take S1A, S1, S1B. Okay, so we have taken this B. Okay, no problem. So now S1 on C and S2 is still on B. Now we need again B. Now S1 C, S2 B. So we have to take S2B. Okay, so we have also taken this. Now S2B. Now we need another B. S1 is on C and S2 is on B. So we have taken this B. Okay, so we have taken this B. Now we need A. Now see, we need A, but here it is C and here it is also C. So we cannot form it by taking S1B. Okay, so we have to backtrack. So we have to backtrack. Okay, so we have to backtrack. Obviously, we have to backtrack. Now see, if we take this B, okay, if we take this B, what? Okay, now we need another B. So we have to take this B because here in S2 we don't have B and here is S1 we have one B. Okay, so we take this B. Now see, here C, here also C. So it is not possible if we take S2's B. So if we check both, we have taken first S1's B, then we have taken S2's B. No one is able to form this S3. So we can say this, that S3 is not able to form using S1 and S2 interleaved, using interleaved. Okay, got it? Okay. So now let's see the third example. The third example says that if S1 is empty, S2 is empty, S3 is empty. Well, true, obviously. If S3 is empty, then no character is needed to form this string. So we can return true. Now look at it constant. So S1, S2 is 100, S3 dot length is 200. Okay. So it is quite low. Now whatever we observe, there are some observations. Okay. First observation is that we can create S3 by using S1 and S2. Okay, like here you can see that S3 has been given and S1 and S2 also has been given. We have to create S3 using S1 and S2 fully. That's why we can say that the length of S3, which is S3 dot length, we can consider the length of S3 will be equal to the S1 dot length and S2 dot length plus S2 dot length, because we will create S3 using S1 and S2. If something has been given that S1 length of like 5, S2 is of length 5, and S3 is of length 3, how can you create this S3? Because S1 has been given 5, S2 has been given 5. So S3 will be 5 plus 5, length of 10. Okay, so this is our first observation. Now, as we said that we need three pointers. One is I pointer, which will keep track of S1, J pointer, which will keep track of S2, and K pointer, which will keep track of S3. Okay, this is respectively. Now we have three cases. The character on S3 of K can present in both the S1 of I and S2 of J. Like one character is present on S3 of K. Okay, this character can be taken from S1 of I and S2 of J if both characters of S2 of I and S2 of J is equal to the S3 of K. Then we have to what we have to do? We have to explore two choices one by one, and if one choice will give me true, we can say that we are able to form S3 by interleaving. Okay, this is the first choice. Second choice, the character on S3 can present in S1 if suppose character, let's suppose character of S3 is not present. Let's suppose character of S3 is not present on S2. It can be present on S1. Okay, then we will take it from S1. If the character of S3, which we need, is not present, is absent on S1, but present on S2, we will take it from S2. Okay, that are the three cases. Okay, now let's go through the code. Okay, first overlook this portion, which in which portion I have written deeply. First, think recursively. Okay, so we have given string s1, s2, and s3. So and we have passes this three string because we have to keep track of these three strings, and I have passes I, j, and k. Why I, j, k? To keep track of s1, s2, and s3. Obviously, okay. Look over. Don't see these lines at first. Okay. First we have created bool result. Okay. First we have created bool result is equal to false. That means we have assumed that it is not possible to form this string s3. Okay. Now see this. If s3 of k is present on s1 of I, and also we have to check I less than s1 dot length, which is second case, that if s3 of k is present on s1 of I, that means we first have to check that I shouldn't be greater than or equal to s1 dot length. So I have checked it that I less than s1 dot length, and s of 1 I is equal to if s3 of k, then result is equal to solve s1, s2, s3. Okay, we have taken ith position. So now explore I plus 1th position. J is as same because we haven't taken J. Now K. Basically, we have taken the kth position, or we can omit this kth position from S3. Now we need K plus 1 position should be matched with some S1 or S2 position. Okay, so we will keep track of K plus 1. Okay, this is the second case. And if s1 of I is equal to s3 of k, and s2 of j is equal to s3 of k, then we have to look both cases. Which case will give me true? I will return it. Okay, like if s1 of I equal to s3 of k and s2 of j equal to s3 of k, then what we will do? First, we will take s1 of I, which is I plus 1. That means we have taken the character from s1 string. That's why we taken ith position. Now we have to explore I plus 1th position. Okay. And same as the above, which is k plus 1. Basically, we have taken the kth position of S3. Now we will have to take k plus 1th position of S3. Okay, this is the case. And the second case is we can take we can take jth position, like we can take the jth position's character from S2. Then we have to explore j plus 1th position, and we have to explore k plus 1th position. Okay, this is the simple funda. Okay, it is. And third case is same, that if S3 of k is present on S2 of j, and also we have to check that j less than S2 dot length. Basically, if j less than S2 dot length, basically we can access S2 of j. If j is greater than or equal to S2 dot length, we are unable to access the position of S2. Okay, that's why I have to check this condition, which is j less than s2 dot length. And if s2 of j equal to s3 of k, basically, if we are unable to find the character on ith position of s of 1, we will see if it is present in jth position of s2. Okay, which is s2 of j equal to s3 of k. Now, same. Basically, we have taken the character from jth position of h2. That's why I is same. Now we have to explore j plus 1 position. Basically, we have taken the jth position, and in h3 we have taken the kth position. Now we have to explore k plus 1 position. Okay, got it. Okay, look over this dp portion. I will explain this. Now return result. Whichever will be the result, I am returning it. Now time complexity. Okay, so basically, whenever I am on a particular position, whenever I am on a particular position or index, what choices I can make? I can take this. I I can overlook it. I can take this. I can overlook it. I can take this. I can overlook it. So we have two choices basically. I can take this or I can overlook. I can take this or I simply overlook it. So we have two choices. So we have 2 to the power n, which is a exponential time complexity. So our constant is 100. So if we go in a way which will give us a exponential time complexity, it will give me a really obviously time complexity error. So we have to optimize this. So what is the process to optimize the recursive process? Obviously, dynamic programming. So I have created a DP array. I have created a DP array. Now, why the DP array size 101, 101, 201? Why it is 3DDP? As we can see this, in each step, three parameters are changing. One is I, one is j, one is k. Okay, in each step, you can see that here I plus 1 changes. You can see here I plus 1 changes, k plus 1 changes. Here you can see j plus 1 changes, j changes, and k changes. So basically, three parameters are changing. That's why I have taken three state DP. And ith maximum is 10100. For the safety purpose, I have taken 101 size. Jth maximum is 100 for the safety purpose same, and kth maximum is 200 for the safety purpose. I have taken 201. Okay, now simple DP. I have taken this DP, then I initialize it with -1. Okay, then if before returning, I have stored the state in DP to store the state. If the result is false, it will give you 0. If the result is true, it will give you 1. Okay, and 0 means false and 1 means true. Okay, now here To memorize it, I have written this line that if dp of I, dp of j, dp of k not equal to -1, return obviously the state or the state which is stored inside the dp, just return it. Just return it. Okay. Now, base case. What will be our base case? Think of it. What will be our base case? Okay. See. So, what will be our base case? Okay. So, if we are able to complete this S3, our K would position something here. Okay. Our K would position something outside the string, which is if the length of the string is S3 dot length, our K will place on S3 dot length because we are able to we are able to make this string. We are able to make this string. And if we are able to make this string, then we can say this S1 is also fully used, and S2 is also fully used. That's why in this process we are able to make S1 and S2. We use S1 fully, we use S2 fully. Then only we can make S3 fully. So this is the base case. If I can say that my ith pointer is equal to s1 dot length and jth pointer is equal to here in this portion jth portion j is equal to s2 dot length and k is equal to s3 dot length, then we can say that we are able to form the s3 string. S3 string. Okay, here we are storing the portion that we are able to form this thing. Basically that's why we are returning true. Okay, so it is our base case. If we are able to form this string, if we are able to form this string, our ith pointer will exhaust, jth pointer will exhaust, and kth pointer will also exhaust. Got it? Now, so this is done. I hope you will clear. Now what will be our time complexity? As you can see that what we are doing in DP, we are just traversing these three states. We are just traversing these three states. If we say that s1 dot length is n, s2 dot length is m, and s3 dot length is something, say L. Okay, our time complexity will be n into m into L. Our time complexity will be this. Okay, and space complexity same. So our time complexity will be this if we use this 3DDP. Now how to optimize this? Let's think of it. See this in one state, like in this example, if we take A from here, A from here, okay, then DBBC from here, our jth pointer will stand in this fourth position, and our ith pointer is present in this position. Okay, and our kth pointer is present on this position. Okay, in this position. Okay, so we can say that our kth pointer is on index number 6 and our jth pointer is index number 4 and our ith pointer is index number 2. So from here we can say that k is equal to I plus j. We can say this, that k is equal to I plus j. We can say this. If k is 6, then we can say I is 2 and j is 4. 4 plus 2 is equal to 6. This optimization we can do that whenever, so we can reduce this case state. You can see we can we can reduce this case state. Sorry. So you can see that we are able to reduce this state. Here we have only two states. Okay, and in parameters we have only I and j. Okay, and same dp state reduced, dp state reduced. Okay, for in which position we have k. I wrote what? I wrote I plus j, I plus j. Okay, same. Okay, now one observation. I already told that if we will creating S3 by using S1 and S2. So S3 dot length should be equal to S1 dot length plus S2 dot length, because if S1 dot length plus S2 dot length is greater than or less than S3 dot length, then we can say that S1 dot length S1, using S1 and S2 we are not able to form S3. So we can use this condition also, like in the beginning, that if s1 dot length plus s2 dot length not equal to s3 dot length, we can directly return false, that s3 cannot be formed using interleaving of s1 and s2. Okay, so by this method the time complexity will boil down to n into n. I hope you understand why. Because we have reduced, because we have omitted the case state. We have omitted the case state using this formula, which is k is equal to I plus j. I plus j. Okay, and the proof is here, that if we have taken aa from s1 and dbbc from s2, our j pointer will be present at index number 4 of s2, and our ith pointer will be present at index 2 of s1, and our kth pointer is on index number 6 of s3. Then we can say that k is j, k is j and I. So we can say from there that k is equal to I plus j, which is 6 is equal to 2 plus 4. It's proved. Okay, so complete time complexity also reduced. So here is the solution of the problem. Thank you, and if you like that video, you can subscribe to my channel for more such videos.